Okay, as we approach the end of our modelling with algorithms journey, we're going to look at another two-stage simplex problem. This time we're going to have a look at one that's got two artificial variables. So, what does it look like to have two artificial variables? Well, just in our previous video, we looked at a linear program that had one artificial variable, and that came about when the origin did not satisfy the constraint. Now, in this situation, see, as usual, I've drawn my linear program and then the graphical solution to this, because it's a two-dimensional case. We now have two constraints, one here and one here, both of which reject the origin. So each of those is going to give me an artificial variable. That's these two constraints here, the bottom two. These two constraints are the reason I cannot use the simplex algorithm as it is with this linear program. I need to use two-stage simplex because of those two constraints. Each of those is going to give me an artificial. So let's have a look at drawing up the initial tableau from this program. So the objective function is just going to remain the same as all of the simplex that we've done. So we're going to subtract the variables across the other side, and then that's going to be left with equal to 0, so that's nice and straightforward. These two constraints, again, just regular simplex constraints. We're going to add a slack variable and then change that to an equality. So we're going to get 2x plus y plus a slack is equal to 96, and then we're also going to get x plus 2y plus a different slack is going to be equal to 72. Okay, that's nice and straightforward. In the previous video, we looked at how to deal with these constraints. So what we're going to do is we're going to subtract a surplus variable. So we're going to x plus 2y subtract a surplus variable. So that will take up any numbers above the number 48 for this constraint, and it will bring it back down to 48. The problem is at the origin, that would have to be a negative number, and we're not allowed that. So what we do is we add an artificial variable. In the previous video, I called them a because there was only one, but now we've got two. I'm going to call it a subscript 1. And that's going to equal 48. Okay, so that's that constraint. That's how we deal with that. Excuse me. And then there's bottom one, exactly the same, except it's going to be a different surplus variable. So let's call it S4, and a second artificial variable. So let's call it A2. And that's going to equal 84. Okay, so that's how we deal with those. Now, we've also got this new objective variable to deal with, which is capital A, and the objective variable in this case is equal to the sum of A1 and A2. In general, it's going to be the sum of all of the artificial variables that you have. We want to express capital A in terms of all the other variables. We don't want in terms of A1 and A2 for the tableau, because we want A1 and A2 to be initial basic variables. So we're going to pull these down from these two constraints. Now, the way we're going to do that is I'm going to add these two constraints together, and we end up with 4x plus 4y minus S3 minus S4 plus A1 plus A2, and that's going to equal 132. At which point I can now replace plus A1 plus A2 with our objective, capital A. Okay, what it looks like in terms of the tableau is usually what I would do is I'll draw these four constraint lines up first, and then the top objective line is going to be just the sum of those two, replacing A1 and A2 with capital A. So let's get all this into the initial tableau, and let's see what we end up with. Oh, there should be a capital A there. Column header. Okay. So the first constraint was 2x plus y plus S1. So we're going to get 2x plus a y plus a slack, and that's going to equal 96. Everything else in that row will be a 0. No objective variables, no other slacks, no surpluses, and no artificials. Okay. The second constraint was x plus 2y, so that's going to be 1x plus 2y this time. And now we've got a different slack, so we called that S2. And again, zeros everywhere else. Then the third constraint, this was the first one that contained a surplus variable and an artificial. So we had 1x and 2y. Then we had -1 in our surplus column. And then we had a +1 in our artificial column. And that equaled 48. And then finally, we had 3x plus 2y. And then a second surplus and a second artificial. And that was 84. Okay, so those are my constraint rows. And you can go straight from linear program to Tableau. That's not a problem. The second row here is our second objective. That is our P objective. That's the ultimate one that we're trying to do for the linear program. That was worked out as -2x minus 3y. Zeros everywhere else. And then here comes our new one. Nice and easy from the Tableau. Just add these two together. We'll end up with an A1 plus an A2, which we replace with a capital A. So we get a 1 over here instead of the A1 plus A2. And everything else in that row is just the sum of these two, the two that contained the artificial variables. So 0 plus 0 is 0. 1 plus 3 is 4. 2 plus 2 is 4. Zeros, 1 negative 1 there. A negative 1 there. And then 132 over there. And there is my initial Tableau. Okay. Now, in an examination setting, that's all you'd be needed to do. You wouldn't need to carry out an iteration of two-stage simplex. You may be asked to describe how you would proceed, but you wouldn't actually need to be able to execute an iteration. But what I'm going to do in this video is just execute an iteration of the two-stage simplex, because then that will help you to describe what you would do. So here is my initial Tableau again, this time running up all in black, and we are going to conduct a ratio test to get us started. So just to remind you, the ratio test will decide where which row we're going to call our pivot row. In terms of which one we call our pivot column, it doesn't actually matter because they're both 4s. So in an examination setting, you could describe, I'll choose either the X column or the Y column because they're both the number 4. We're trying to minimize A, so you will need to choose the most positive number in this row. So either 4. So I'm just going to choose X just because it comes first alphabetically, no other reason. And then let's conduct a ratio test. So pop a row over on the right hand side of the Tableau, and then we're going to do 96 divided by 2 to give us 48. 72 divided by 1 is 72. 48 divided by 1 is 48. And 84 divided by 3 is 28. Okay, so those are our 4 results from our ratio test. And just to remind you, what the ratio test does is it decides how far we can move in those directions. So we can move in the X direction. We had the first ratio test value was 48, so one of the constraints there at 48. The second one was 72, so that was over here. The third one was 48 again. You can see there's 2 there meeting at 48. And then finally the 28, which is there. And when we're conducting simplex, we don't want to shoot past a constraint boundary for fear of going too far. So we always choose the smallest result from the ratio test. Okay, so in that case, that's this one here. It's the smallest positive value from the ratio test. So that has chosen our pivot row. So therefore, that is our pivot. Okay. So now to conduct an iteration. What we do first is we're going to take that pivot row and divide it by the pivot element to give us row 6 divided by 3. That just ensures that we're going to get a 1 in there for our pivot. So we've got zeros there. That's going to be a 2/3. That's a 0, 0, 0, negative a third, 0, positive a third, and then 28, which is actually the result from the previous ratio test. Okay, so that's our pivot row. We can also fill in some columns really quickly as well. Anything that was a pivot column before, except for this one, is going to remain a pivot column. So we're going to end up with A1 as being a pivot column. So 0, 0, 0, 0, 1. we've got S1 and S2, and then we've got A and P. These are the columns that contain 1, 1, and everything else is a 0. This one moves to there. Ultimately, what we're trying to get to is 0, 0, 0, 0, 0, 1, so that won't be that anymore. So we can fill out those really quickly. So you're going to get 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, and that one's already done. Excellent. Okay, and because we want this to be a pivot, then we know that that's going to be 0, 0, 0, 0, 0, 1. Excellent. Okay, so we've only got those values now to fill out in our Tableau. So what I recommend is just writing down the command on the left-hand side of the Tableau as to exactly what it is you are doing. So I want to make this a 0. So what I'm going to do is I'm going to start with row 1, so R1, and I'm going to subtract 4 times the pivot. And the pivot is the number 1. So I'm just subtracting 4 times the number 1 from this 4. So it's going to be 4 times the pivot row. And if I do that for all of those elements, the next one is plus 2. So row 2 plus 2 times the pivot. Then I've got a positive 2, so I need to do row 3 subtract 2 times the pivot. Then my next elements are both 1s, so I need to do row 4 subtract the pivot, and then finally row 5 subtract the pivot. And what that'll do is it'll ensure all of these are the number 0. So these are my commands that I'm going to carry out to fill in the rest of these values on the Tableau. Okay, so I'm going to do the first column, then I'm just going to fill out the rest of the numbers. Okay, you've seen me do this so many times if you've seen my videos already. It is exactly the same process. So let's do the Y column. I'm going to start with the number 4 on my calculator, not 4 squared. Start with the number 4, and then we're going to subtract 4 times the pivot. So that's minus 4 times the pivot. Now the pivot element in that column is a 2/3. Okay, so that's the number I'm going to be subtracting as my PI value there. So times 2/3. Okay, and that gives me an answer of 4/3. So that is the number that goes in that box there. And let's repeat that process for the rest of the column. So row 2 plus 2 times the pivot. Well, row 2 was a -3, and then I'm going to plus 2 times the pivot, which is 2/3. That gives me minus 5/3. And then my next element was a 1. And I'm going to subtract 2 times the pivot. And that gives me -1/3. And the next two are actually exactly the same because I both start with a positive 2 and I'm both subtracting the pivot element. Okay, so they're both going to be the same number in here. So it's going to be 2, subtract the pivot element, which is 2/3. So that gives me 4/3. So that's the number that gets written in these two spaces. And if I follow those same commands for the rest of these with these elements as PI, then I end up with zeros everywhere there and a -1. Which actually you can fill out quickly again because there's a 0 in the pivot row. And then I get a 1/3, -2/3, 2/3, a 1/3, and a 1/3. And then over here I get -4/3, positive 2/3, -2/3, negative a third, negative a third. And the right hand side values are 20, 56, 40, 44, and 20. Okay, so that's the first Tableau, the first iteration of two-stage Simplex. Now, we have not met the first objective because the A value is still positive. Okay, it's not 0 yet, so we are not yet in the feasible region. And if we pull the numbers from this table, we're going to end up with A is 20, P is 56, slack 1 is 40, slack 2 is 44, Artificial 1 is 20, and X is 28. Everything else is 0. Okay, so these are the columns that are full of junk. So Y is 0, S3 is 0. This is classed as a column full of junk because it doesn't contain 1, 1. Okay, it's got one negative 1, so it's still a column full of junk. S4 is also 0, and A2 is 0. Okay, so that is where we are at currently. In terms of the graph, we are at the point X is 28, Y is 0. So we have moved from the origin to this point here, which we can see is not in the feasible region yet. After a second iteration, we will be, because we would have either moved up this constraint to point D, or we would have moved along this constraint further to the point C. Okay. All right. I'm going to stop this video there. If you wanted to complete the problem, then I invite you to do so. It is not one you'd see in an exam to go from start to finish, but you would need to be able to come up with the initial tableau, which is what we did here, and then you might need to describe in words how you would proceed. All right, thank you very much for watching.